Hi students, let's do another problem in reciprocity theorem. Here the question is, in the given network, find the voltage Vx. Okay, this is the voltage Vx and verify the reciprocity theorem. So this voltage Vx is the voltage across the capacitor, right? Vx is the voltage across the capacitor, which is minus 2J. And here, this should be a single source and we have a single current source over here. It's called as 20 angle 90 degree amperes. So we have a current source over here. In the last video, in the last problem that we did, it was a voltage source and they were asking us to find the current. Now it is reverse. Now the current source is given and here they are asking us to find the voltage across the element, voltage across this capacitor. Okay. So the method is basically the same. First, what we have to do is, first I need to find the value of Vx. Okay. And then after that, what I will do is, I will exchange the position of my excitation and my response. So here this 20 angle 90 degree ampere is my excitation and the voltage across the capacitor is my response. So let's do this question. So first I will apply mesh analysis, right? Because I'm trying to find the value of Vx. So if I want to apply mesh analysis, let this be I1. Okay, let this be I1 and let this be I2. Okay, I2. Okay, so in that case, what is the voltage across the capacitor? Voltage across the capacitor is equal to Ohm's law, right? Ohm's law is I into R. What is the value of I? The value of I is I2. Okay, it is I2. It is I2 and not minus I2 because this I2 is flowing from a higher potential. See, this is plus. So this is the higher potential and this is a lower potential. So the current I2 is flowing and the current direction, look at the direction, it's clockwise, which means in this branch it is going downwards, which means it is going from a higher potential to a lower potential. That is what a current is supposed to do, right? A current is always supposed to flow from a higher potential to a lower potential. So it is I2. So I2 into Ohm's law. Ohm's law is I into R. So the value of I is I2 and the value of R is the reactance of the capacitor, minus 2J. So this is the equation for Vx. Okay. So now I found, so which means to find the value of Vx, I just simply need to find the value of I2. Okay, that's what it means, right? I just simply need to find the value of I2. So now let me apply mesh equation. So equation for mesh 1. Equation for mesh 1, over here it is. Here there's already a current source, so which means we don't need to apply any Kirchhoff's voltage law, right? We don't have to apply any KVL. You can simply write the current equation because the current in this branch is I1 and this current already in this branch is given as 20 angle 90. Or in other words, I1 is equal to 20 angle 90. Therefore, I1 is equal to 20 angle 90. 20 angle 90 is also called as 20J. If it's just simply check in the calculator. Okay, so this is the value of I1. So I found the value of I1. Next is equation for mesh 2. Equation for mesh 2, which means I2 is positive and I1 is negative. Therefore, and I1 is touching which all elements in this mesh? 10 ohm and this 5J. So it is 10 plus 5J. And what about I2? I2 is touching this 10 ohm over here. I2 plus I2 is touching this inductor over here, 5J. Then it is touching this capacitor over here, first minus 2J. It is touching this inductor over here, so it is plus 5J. Okay, that's it, right? Is equal to 0. That's it. Or in other words, minus I1 into 10 plus 5J plus I2 into 5 plus 5, 10, 10 minus 2 is 8. So 10 plus 8J is equal to 0. Okay, and of course we already know what is the value of I1. I1 is equal to 20J. So we have minus 20J into 10 plus 5J plus I2 into 10 plus 8J is equal to 0. Or in other words, I2 is equal to 20J into 10 plus 5J by 10 plus 8J. This is the equation for I2. If this is the equation for I2, then I can now write the equation for Vx. Therefore, Vx is equal to, the equation of I2 is 20J into 10 plus 5J by 10 plus 8j into minus 2j. Okay, minus 2j, and here j into j is minus 1, minus and minus will become plus, so and 22 is 40, so you will get 40 into 10 plus 5j by 10 plus 8j. Okay, this is the value of Vx. Let me find the value of Vx over here. So Vx is 40 into bracket 10 plus 5j divided by bracket 10 plus 8j. Okay, and you will get the answer as 34.146 minus 7.317j. This is also equal to option, let me see, 1. This is also equal to 34.922 angle minus 12.095 degree volt. Okay, so this is the value of Vx. Now what I'm going to do, sir, I'm going to reciprocate this equation. I'm going to reciprocate this circuit. I'm going to exchange the position of the source with my excitation with my response. So therefore my circuit will now become like this. On exchanging, the circuit will now become like that. Is, let me draw it. So here instead of current source it will be Vx. Okay, instead of current source over here it will be Vx. So it is, I need to mark like this. Okay, instead of current source it is Vx. This is the higher potential, this is the lower potential, Vx. Okay, this Vx is, remember, this Vx is not a voltage source. It is not a voltage source. It is a voltage drop. It is a potential drop. It is a voltage across a capacitor, which is not a voltage source. That is why we have to show, if it is not a voltage source, we have to show it like that. Okay, so it's not a voltage source, it's a voltage drop. Okay, this is a resistor and an inductor, 10 ohm and 5j. This is 10 ohm, this is 5j, and we have over here as a 5j and minus 2j, 5j and minus 2j. Okay, and over here instead of Vx we'll put the current source. So we have a current source over here. There you go. This is the equation. This is 20 angle 90 degree or 20J. Okay. So this is the new circuit, and here also you need to find the value of Vx, and according to reciprocity theorem, this Vx and the previous Vx should be the same. Let me see. So let's do this question. So here in this question, there are only two meshes, right? Only two meshes. This is 1 and 2. Only these two meshes are there, right? This is not a mesh. This is an open mesh. So there's no current over here. So there are only two meshes over here. So I will mark this as I1. I will mark this as I2. Okay. And then I write the equation for I1 and I2. So what is here? What is the equation for Vx? What is the equation for Vx? So what is Vx over here? Here Vx is called as the voltage across the capacitor. What about here? Here Vx is called as the voltage across this branch. Vx is the voltage across this branch, or Vx is the voltage across 10 plus 5j. Vx is the voltage across the 10 plus 5j. And what is the voltage means? Ohm's law. V is equal to I into R. What is the value of I? The value of I is minus I1. The current is minus I1. It is actually minus I1 into, and the resistance is 10 plus 5j. Because Vx is the voltage across 10 plus 5j, right? It is a voltage, Vx is the voltage across this branch, and the impedance in this branch is 10 plus 5j. Okay, so the current is minus I1. Why it is minus I1? Because look at the direction of the current. The current in this branch, the current is flowing from bottom to top. It is flowing from bottom to top, which means, and look at the potential of Vx. Vx, this is the higher potential, this is a lower potential. Current always flows from a higher potential to a lower potential, but this I1 is flowing from a lower potential to a higher potential, right? So it is going in the opposite direction of diffusion. Diffusion is what is diffusion? There is a higher concentration of impurities is flowing to a lower concentration, right? That is this just like that. So this is current is supposed to flow from a higher concentration, higher potential, because here the electrons are high, here the electrons are less. So current should be flowing from a higher potential to a lower potential. So here it is going the opposite. It is flowing from a lower potential to a higher potential. So therefore it is must be 10 plus. So it is minus I1. Okay. So Vx is minus I1. So now which means to find the value of Vx, I simply need to find the value of I1. So now let me apply the equation for mesh 1. Equation for mesh 1, it is, here we have I1 into 10, and this is 5 plus 5, 10, 10 minus 2 is 8. So 10 plus 8j minus I2 into minus 2j is equal to 0. Okay, this is the equation, or in other words it is I1 into 10 plus 8j plus I2 into 2j is equal to 0. This is the equation for mesh 1. Next is equation for mesh 2. Equation for mesh 2. Okay, and here the equation of mesh 2 is, you don't have to apply any Kirchhoff's voltage law because already the current is shown over here. The current in this branch is I2, and the current source in this branch is, it's going the opposite direction, which is 20 angle 90. Therefore I2 is equal to minus 20 angle 90. I2 is equal to minus 20 angle 90, or I2 is equal to minus 20j, which means now I can find the value of I1, right? So what is I1? Here I1 into 10 plus 8j, and here I2 is minus 20j, right? So it is minus 20j into 2j is equal to 0. J into j is minus, minus and minus becomes plus. So we have I1 is equal to minus 40 by 10 plus 8j. So I1 is equal to minus 40, right? Here this is plus 40. So when it comes over, it becomes minus 40. Minus 40 by 10 plus 8j. So now I found the value of I1. So now I need to substitute that over here. So therefore we have Vx is equal to minus 40 by 10 plus 8j into 10 plus 5j, which is equal to, minus and minus becomes plus. So we have 40 by 10 plus 8j into 10 plus 5j. See, look over here, this is the equation for Vx. Look at the equation of the previous Vx. Look at the equation of previous Vx, 40 into 10 plus 5j by 10 plus 8j. Over here also same thing, 40 into 10 plus 5j by 10 plus 8. So which means both the Vx is same value, correct? Both of them are having the same value. So therefore Vx is equal to 34.146 minus 7.317j, which is also equal to 34.922 angle minus 12.095 degree. 12.095 degree minus 12.095 degree volt. This is the equation for Vx, which means both the cases are same. Both the Vx over here and the Vx in the previous circuit is the same. Hence, the reciprocity theorem is verified. Okay, so this is how we do the question. So now let's do this question. Find the voltage V and verify the reciprocity theorem. So see over here also you can see that the source is a current source over here, and V is the voltage across this resistor. V is the voltage across this 5 ohm resistor, and see, this is the higher potential and this is the lower potential, right? So that means too much of charges are over here and too little charges are over here. That's what this means. So this is a higher potential, this is a lower potential, which means the current is actually flowing from left to, is flowing from right to left. Yes, it is flowing in this direction. That's what it means. Okay, so this is the voltage, and let's do this question. So here I will basically apply mesh analysis, right? So if I'm going to apply mesh analysis, let this become I1, let this become I2, let this become I3, and let's write the equations of I1, I2 and I3. So equation for mesh 1, equation for mesh 1 is, you can see that there is already a current source over here, so you don't have to apply KVL because we already know the value of current, and the value of current is equal to 10 amperes, right? It is plus 10 and not minus 10 because this I1 is flowing in the same direction of the current source, right? It is flowing from bottom to top, and current source also flowing from bottom to top. Therefore I1 is equal to 10. Next is equation for mesh 2. That is the equation. Okay, equation for mesh 2. So equation for mesh 2, here we have here if it is mesh 2, then I2 is positive and I1 and I3 are negative. So which means we have minus I1 into, and I1 is in this mesh, I1 is touching only this resistor, that is 4 ohm, plus I2 into, and I2 is touching all these three resistors, 4 plus 2 6, 6 plus 5 11, and I3 in mesh 2, I3 is touching only this resistor, so it is minus I3 into 5 is equal to 0. Okay, this is the equation. So of course we already know I1 is equal to 10. I can substitute that over here, so this will become minus 40, right? Or in other words, this is 11I2 minus 5I3 is equal to 40. Okay, this is the equation for mesh 2. Next is equation for mesh 3. Equation for mesh 3, here we have in mesh 3, it is actually I1 is negative, I1 and I2 are negative and I3 is positive. So which means we have I1 into, and I1 is touching only this resistor over here, so it is I1 into 6 minus I1 into 6 minus I2 into, and I2 is touching only this resistor over here, so it is minus I2 into 5 plus, and I3 is touching these three resistors, which is 6 plus 8 14, 14 plus 5 19, so we have minus plus I3 into 19 is equal to 0. There you have it. This is the equation, and of course I1 is equal to 10. I can substitute it over here, so this becomes minus 60, or in other words the equation is minus 5I1 plus 19I3 is equal to 60. This is the equation. Okay, and what am I supposed to find over here? Sorry, I think I made, yes, correct. Okay, minus 5I2, right? Yes, okay, minus 5I2, right? So what am I supposed to find over here? See, I need to find the value of V. That's my question. So what is V? V is the voltage across the resistor, right? So V is equal to Ohm's law, I into R. So what is the value of I? I is equal to, let me see, I is equal to I2 minus I3, right? I is equal to I2 minus I3, because I2 minus I3 is the current in this branch. Okay, why is it I2 minus I3 and not I3 minus I2? Because I2 is flowing from a higher potential to a lower potential, which is what a current is supposed to do. As current is supposed to flow always from a higher potential to a lower potential. Therefore I2 is following that basic law. It is flowing from a higher potential to a lower potential. That's why it is plus I2. And why is it minus I3? Because I3 is flowing from a lower potential to a higher potential, which is not what a current is supposed to. A current is always flowing from a higher potential to a lower potential, which means the current direction of I2 is assumed to be negative. It's assumed to be the opposite direction. That is why it is minus I2. So therefore, that is why it is minus I3. So it is I2 minus I3. Okay, and what is the resistance is 5. So this is Ohm's law, I into R. This is the voltage across the 5 ohm resistor. So which means to find V, I need to find the value of I2 and I3 only. I don't need to find the value of I1. I1 is already shown, no use. I need to simply find the value of I2 and I3, substitute it over here to find the value of V. So here I need to solve these two equations. So how will I solve it? One way of solving is I can multiply this equation with 5 and I can multiply this equation with 11. Okay, see, because in that case these two terms will get cancelled each other. So in that case this will become 55i2 minus 25i3 is equal to 40 into 5 is 200. Okay, and over here also, here you have 11 into 5 is 55, so you have minus 55i2. Okay, and here 19 into 11 is, let me see what is 19 into 11. 19 into 11 is 209, right? 209. So this is plus 209. I3 is equal to 660. Okay, so I can now, if I add these two will cancel each other. This is 209 minus 25. 209 minus 25 is 184. So this is 184 I3 is equal to, and this is 860. Therefore I3 is equal to 860 by 184. 860 divided by 184, which is 4.674. So for I3 is equal to 4.674 amperes. This is the value of I3. If this is the value of I3, then I can find the value of I2 also, right? What's the equation for I2? I2 is 40 plus 5i3 by 11. I2 is equal to 40 plus 5i3 by 11, which is equal to 40 plus, what is I3 is 4.674. So 5 into 4.674 by 11, which is equal to, let me see, so you have over here as 40 plus, again bracket, 5 into 4.674 close the bracket again, divide by 11, and you will get the answer as 5.761. So I2 is equal to 5.761 amperes. So in that case, so I know the now I know the value of I2 and I3. So therefore V is equal to I2 minus I3 into 5, right? I2 minus I3 into 5. So what is the value equation for I2 is 5.761 minus I3 is 4.674 into 5, which is equal to, let me see, so we have 5.761 minus 4.674 divide into 5, and you will get the answer as 5.435. So V is equal to 5.435 volt. Okay, this is the voltage across the 5 ohm resistor. Okay, so now what I am going to do is I am going to reciprocate, or I am going to reciprocal this circuit. That means I am going to exchange this is my excitation, and the voltage across the 5 ohm is my response. So when I am going to exchange it, then in that case then the voltage in this branch, or the voltage across this branch is V, and the current across or the parallel to 5 ohm is 10 amperes. Just simply exchange the position of the excitation response exactly the way how it is. That's all. So therefore the next circuit is like this. That is, let me draw the circuit over here. It is over here like this, and the other one is over here. Okay, and now let me draw the Wheatstone bridge, that is these two. So to draw the Wheatstone bridge, okay, this is one resistor over here, this is another resistor over here, alright, and we have one more resistor also over here. Okay, and this is the voltage across the branch. That is, instead of a current source, I replaced it with the voltage. The current across this branch, I replaced it with the voltage across this branch. And here the voltage is in parallel to 5 ohm. So in that case, in the same way, the current also will be in parallel with this. It's also in parallel to the resistor, right? So this is equation will become like this, or I can draw like this or like this. I'll use a different pen. There, okay. So this is the current source. There you go. Okay, this is the current source, and here the value is, this is 2 ohm. This is, let me see, 8 ohm, 6 ohm, 4 ohm. 8 ohm, 6 ohm, 4 ohm, and this resistor is 5 ohm. Okay, so this is the equation. This is how we draw it. Okay. So now let's now here I need to find the value of I. What is the value of the current source? The value of the current source is 10 amperes. So 10 amperes is the current source over here. Okay, 10 amperes. Okay, when you're drawing in your book, make sure the diagram is a little bit more bigger. Okay, I hope you can see this diagram very clearly. Okay, all right, so let's do this question. So here the thing is, how many meshes are there over here? Here in this circuit, this is not a mesh, right? This is an open mesh. So how many meshes are there? 1, 2, 3. There are 3 meshes. So let's write the equation for all the 3 meshes. So equation for mesh 1. Equation for mesh 1, it is over here. If mesh 1 means, then this is I1, this is I2. Let me mark the direction of I1. This is I1. This is I2, and this is I3. Okay, I3. That is the if you look very carefully, the I1 is the mesh in this cut. This is mesh 1. These 3 resistors. Okay, this forms the mesh 1. Okay, this forms the mesh 1, and I2 is this mesh. That this mesh is consisting only of a resistor and a current source. Okay, that is I2. And what about this I3? I3 is this mesh. That is this current source and these 2 resistors. That is mesh 3. Okay, so mesh 1 equation is let me see, 4 plus 2 8, 4 plus 2 6, 6 plus 5 11. So we have 11 I1 minus, and here it is 5 I2. 5 I2, 11 I1 minus 5 I2 is equal to 0. Okay, this is the equation for mesh 1, that is over here. That's all, right? That's the only equation. Now what about equation for mesh 2? Well, if you look over here, this is mesh 2, right? This is mesh 2, this is mesh 3, and in between mesh 2 and mesh 3 there is a current source. So therefore this is called as a super mesh. That is, mesh 2 and mesh 3 is a super mesh. That is, these 3 resistors is actually a super mesh. So which means equation for super mesh 2 and 3. Okay, so there are 2 equations. So what are the equations? So if you are writing the equation for super mesh, which means I2 and I3 are positive and the remaining current is negative. Remaining current means only I1, right? So therefore I2 and I3 are positive and I1 is negative. So this is a super mesh, and this super mesh I1 is touching only this resistor, so it is minus 5I1, and the I2 and I3 is positive, plus, and what about I2? I2 is touching only this resistor over here, so it is 5I2, and I3 is touching these 2 resistors, that is 6 plus 8, 14, so it is plus 14I3, and there is no current source anywhere over here, so it is equal to 0. This is the equation for super mesh, that is these 3 resistors. Okay, now you need to write the equation for the current source, and look at the direction of the current source. It is flowing from left to right, so therefore the equation for the current source is, let me see, I3 is also flowing from left to right, right? Every current is in the clockwise direction, so for I3 is also flowing from left to right, but I2 is flowing from right to left. So therefore the equation for the current source is I3 minus I2 is equal to 10. I3 minus I2 is equal to 10. Okay, So here there is no I3, so which means I can remove I3 or I can substitute the value of I3. Here I3 is equal to 10 plus I2, right? I3 is equal to 10 plus I2. So I can substitute that over here. So in that case, this will become minus 5I1, and here this is plus 5I2 plus, and this is 10 plus I2, right? 10 plus I2, so this will become 140 plus 14I2 is equal to 0, or in other words it is minus 5I1 plus 14I2 is equal to, not 14 plus 5 19, so plus 19I2 plus 19I2 is equal to minus 140. Okay, this is the second equation. So this is the first equation, this is the second equation. Now I can solve I1 and I2. So solving I1 and I2, let me see, 11I1, let me see how to do this. 11I1 minus 5I2 is equal to 0, and here is minus 5I1 plus 9. So in the same way, here also I will multiply this with 5, and here I will multiply this with 11. So if I multiply with 5, I will get 55I1 minus 25I2 is equal to 0. 55I1 minus 25I2 is equal to 0. Now what about the other equation? If I multiply with 11, it becomes minus 55I1 minus 55I1, and 19 into 11 is, I already did that, right? 19 into 11 is 209. So 19 into 11 is 209 plus 209I2 is equal to 140 into 11. What is 140 into 11? Let me see. 140 is minus 1 is 1540. So this is minus 1540. Minus 1540. Okay. Adding it up, these two will get cancelled. This will become 209 minus 25. 209 minus 25 is 184. So this is 184I2 is equal to minus 1540. Therefore, I2 is equal to 1540 divided by 184 is equal to 8.37. So this is minus 8.37. If this is minus 8.37, then I3 is equal to I2 plus 10, right? So therefore I3 is equal to 10 minus 8.37, which is equal to 1.63, right? This is equal to 1.63. So I3 is equal to 1.63. So I3 is equal to 1.63. And if I3 is equal to 1.63, now what is the value of I1? Now only I1 is remaining, right? What is the value of I1? Is equal to 5I2 by 11, right? 5I2 by 11. So therefore I1 is equal to 5I2 by 11, which is equal to 5 into minus 8.37 by 11, which is equal to, let me see, that is 5 into 8.37 divided by 11 is equal to 3.805, which means this is minus 3.805 amperes. Okay, so I1 is equal to minus 8.305, I3 is equal to 1.63 amperes, and I2 is equal to minus 8.37 amperes. Okay, so now I need to write the equation for voltage. So what is the volt? So what is volt? V is the voltage across this branch, which is voltage across the 4 ohm plus voltage across the 6 ohm, right? This is the volt V. V is the equation. So you need to write the equation for the voltage across the 4 ohm plus voltage across the 6 ohm. So what is the voltage across the 4 ohm? You can see this is the higher potential, this is the lower potential, which means in this resistor, this is having the highest potential, this is having the lowest potential, right? So which means in this resistor, if this is the highest potential, then this is the lower potential. And this resistor, if this is the lowest potential, then this is the higher potential. Which means, so this is the higher potential, lower potential over here. This is the higher potential, this is the lower potential. Okay. Now let's look at the direction of current I1, right? So the I1 is the current through 4 ohm. And what about 6 ohm? I3 is the current through 6 ohm. So I1 is the current across the 4 ohm and I3 is the current across the 6 ohm. So is it plus I1 or minus I1? Look at the direction of current. It's a clockwise direction, right? Clockwise direction. I1 is flowing in the clockwise direction, but it is flowing from bottom to top. It is flowing from bottom to top. Just hold on. Okay. Okay, now you're not confused. So this is flowing from bottom to top, or it is flowing from a lower potential to a higher potential, right? I1 is flowing from a lower potential to a higher potential, which is the opposite of the current that is actually flowing through the 4 ohm, because current always flows from a higher potential to a lower potential, but I1 is flowing from a lower potential to a higher potential, therefore it is minus 4 I1. So the voltage across 4 ohm is minus 4 I1, okay? Plus, now what is the voltage across 6 ohm resistor? The current across 6 ohm resistor is I3, right? I3 is the current. This is I2, this is I3. I3 is the current through the 6 ohm resistor. And this, what about I3? I3 is also flowing in the clockwise direction, right? It is also flowing in the clockwise direction, and also it is flowing from bottom to top, right? Or this I3 is also flowing from a lower potential to a higher potential. But the current across 6 ohm is flowing from a higher potential to a lower potential. The current is flowing in this direction. So it is flowing from a higher potential to a lower potential. But I3 is flowing from a lower potential to a higher potential. So therefore, it is minus I3. So therefore, voltage across 6 ohm is minus 6 I3. This is the voltage across. This is the voltage across the 4 ohm plus voltage across the 6 ohm resistor. This is the voltage across that branch. So in that case, what is the equation for I1? Is minus 3.805. So this is equal to minus 4 into minus 3.805 plus this is minus 6 into, what about I3? I3 is 1.63. 1.63. This is the equation. Or this is equal to 4 into 3.805 minus 6 into 1.63. This is equal to, let me see. So here you have 4 into 3.805 minus 6 into 1.63, and you will get the answer as 5.44. 5.44 volt. This is the value of voltage. So in the previous circuit, what is the value of voltage? We got the answer as 5.435. Here it is 5.435 in the previous circuit, whereas here it is 5.44. So a slight difference, right? So which means both of them are almost same. So in that case, hence the reciprocity theorem is verified. Okay.